Hello, my dear student. I'm Jayendra Pujari. I'm gonna talk about today's topic, image formation on convex and concave lens. This is convex lens and this is concave one. Now, I'm gonna talk about how images are formed on convex lens and concave lens. This is a convex lens. The middle surface of this lens is thick, I mean wide, whether the side is very light, I mean thin one, mark it. Okay? If we draw this convex lens, it will be look like this, mark it. But this is a concave lens. Middle surface is lighter than the peripheral part. If we draw this, it will look like this. We need to know some point of this lens. These are principal axis. I have already been said these points you've seen are optical center. What is the name of the center? This is called optical center. These are focus point. These are center of curvature. In this lens, the focus point and center of curvature are in this side, whereas the center of curvature and focus point are in this side in case of this lens. That means we get two center of curvature and two focus point for each lens. In case of concave lens, it is also same. In case of image formation, we need to know regarding this point first. Okay, enjoy this video. You'll have idea. My dear student, you need to know some special characteristics of this lens before to have the idea regarding image formation on convex and concave lens. This is a convex lens. It is also called convergent lens. Why is it called convergent? Because when some parallel rays refracts on this lens, after refraction, all these rays make convergent towards a point in the principal axis. This point is called focus point. Okay? In the same way, concave lens is called divergent lens. Why is it called divergent? This is a concave lens. In case of this lens, all parallel rays refracts cannot accumulate in a point in the principal axis. These parallel rays, after being refraction, get divergent. Therefore, this lens is called divergent lens. Okay? If we extend the lines against the refracted divergent rays, this line will contact in a point in the principal axis. This point in the principal axis is called focus point in case of concave lens. It is not real. It is actually virtual. It is seemed that the refracted divergence rays come from this point. Okay? In summary, we can say convex lens is convergent because it gets convergent the parallel refracted rays, whereas the concave lens is divergent because it gets divergent the parallel rays on refraction. We need to know the rules of refraction on convex and concave lens. Number one, the incident ray which incident on the convex lens parallel to the principal axis after refraction goes through focus on the other side of the lens. We must know this. On the other hand, the incident ray which incident on the concave lens parallel to the principal axis. After refraction, rays goes divergent way on the other side of the lens. If we draw a line against the divergent rays, then it will be seen that the line crosses a point on the principal axis of other side. This is the focus point of this lens. It is actually virtual point, or it is virtual one. Mind the focus point of the diagram you have seen. The blinking point is the focus point. Again, you need to know a ray of light passing through the optical center of the convex as well as concave lens both, no diversion occur. It is passing through straight line. In this lens that you have seen that the rays are passing through optical center. Therefore, no deviation of rays occur. You need to know these rules to have the idea of image formation on convex and concave lens. This is an important rule of convex and concave lens. Okay? A ray of light passing through the principal focus incident on convex lens after refraction emerges parallel. Mind it, this ray is passing through the focus point and being refraction it goes parallel to the principal axis. Okay, in case of concave lens, all parallel rays to the principal axis being refraction goes divergent. It have already been said. But the ray coming towards the focus being refraction, the rays goes parallel to the principal axis. Don't forget, the rays towards the focus point being refraction does not reach the focus point. Alright, look where am I standing? I'm standing the distance in between infinity and center of curvature, that is twice half of the convex lens. And where does the image is formed? The image is formed the distance in between center of curvature or twice half and f of the lens of other side. In this regard, the image is smaller than I. The image is real and inverted one. Okay? My dear student, it is an interesting one. Try to understand. If the object is in between infinity distance and center of curvature of the convex lens, the image will always be formed between the center of curvature and focus of the other side of the lens. In summary, we can say the image is always be shorter than the object and it is real and inverted image. Now look at me. Where am I standing? I am standing in the center of curvature or twice half of the convex lens. Where the image is formed? The image is formed in the center of curvature of the lens of other side. What type of image is formed? The image is same size with me, but it is inverted and real one. My dear student, in summary, I want to say if the object is in the center of curvature of the convex lens, the image will be formed in the center of curvature in the other side of the lens. Image will always be same size as the object is and it will be inverted and real. Okay? Now I am standing at the focus point of the convex lens. Where the image is formed? The image is formed in the infinity distance of convex lens on the other side of the lens. Therefore, I am unable to show you the image, where is it? Okay? In summary, I want to say that if the object is in the focus point of the convex lens, the image will be formed in the infinity distance of the other side of the lens. Now look at me. Where am I standing? I'm standing in between the optical center and the focus point of the convex lens. Where does the image is formed? Mark it. The image is formed in between the infinity distance and the center of curvature of same side of the convex lens. The image is virtual and erect. Okay? I mean, if the object is in between optical center and focus point of convex lens, the image will be formed in between infinity distance and center of curvature of same side. Image will be enlarged, erect, and virtual. My dear student, now I am going to talking about image formation on concave lens. This is, you have seen, is a concave lens. In case of concave lens, image will always virtual. It is an interesting one and you need to know. If the object is in infinity distance, in case of concave lens, image will be formed in focus point. Image will be virtual, minute, and erect. Okay? Here, the blinking point is the minute image of the object. What's to me? I'm standing in between the optical center and the infinity distance of the concave lens. The image is formed in between the focus point and the optical center of the concave lens. I'm standing here. My image is formed in between the focus and the optical center of the concave lens. In case of concave lens, the image will always be virtual and shorter than the object. Here I am the object, and notice the image. It is seen very shorter than the object. Okay? In summary, I want to say that if the object is in between the optical center and the infinity distance in the concave lens, the image will be formed in between the focus and the optical center of the lens. The image will always be virtual, shorter, and erect. Notice it. Here, the object and the image is same side of the concave lens. Don't forget that if the object is in infinity distance in the convex lens, the image will be formed in the focus point of the other side of the lens. Image will minute, real, and inverted. Okay? Now, what's to me where I am standing? I'm standing in between focus and center of curvature of the convex lens. Where does the image is formed? The image is formed in between infinite distance and center of curvature of the convex lens. I mean, I want to say this, if the object is in between center of curvature and the focus point of the convex lens, the image will be formed in between the infinity distance and the center of curvature of other side of the convex lens. Image will be real, inverted, and enlarged. Okay? Alright, my dear student, these are all regarding the image formation on concave and convex lens. Goodbye for today.